Greetings, mathematicians. In this video, we're going to be learning about some more operations with polynomials, specifically multiplication. But first, we'll start with a warm-up reviewing a couple of problems here. So go ahead and pause this video, give these problems a try, and then come back to check your answers. All right, now that you've had a chance to try the warm-up, here are the solutions. Give those a look. And then we'll get ready to move on to multiplying polynomials. All right, we're going to start with multiplying binomials, so two terms times two terms. And there are a couple of different methods you can use, but we're going to start with something called the box method. It's very visual and relates back to the area model that you may have used in previous courses. So here's our problem. We've got 4x plus 6 and x plus 2. So if you're going to use this box method or this area model, your first step is to set up a 2 by 2 box. And the reason it's 2 by 2 is because you're doing a binomial times a binomial, something with two terms times two terms. If you were to do something with a trinomial, for example, that had three terms, then one side of your box would have three sections on it. It might be a 2 by 3 box if you were going to do a binomial times a trinomial, for example. So here is what your 2 by 2 box looks like. And on the outside, you're going to label your two binomials. Now, because multiplication is commutative, remember 2 times 3 is the same thing as 3 times 2. That means 4x plus 6 is going to be the same thing as 4x plus 6 times x plus 2 is going to be the same thing as x plus 2 times 4x plus 6. That means it doesn't matter which direction you label this box. You can put the 4x plus 6 here, or you can put it on the side. It doesn't matter if you happen to switch those, but along one side of the box, you put your 4x plus 6, and along the other side of the box, you put your x plus 2. And then to get the inside, there's 4 like little squares there. To get those, you're going to multiply each row and column to get each cell. So for example, this first cell here is in the first row, first column. So to get that value, I'm going to multiply the value from the first row and the first column. So that's the 4x and the 1x. So 4 times 1 is 4, x times x is x squared. Now to get this next one, that is in the first row, second column. So 1x times 6, which is 6x. This bottom left, that is in the second row, first column. So 4x times 2, which is 8x. And then the last one, so 6 plus 2, which is 12. So you'll get 4 terms. And then the last step here, we're going to combine our like terms. And if we look through here, we have a 6x and an 8x that are like terms. We'll put those together. So our final answer will be 4x squared plus 6x plus 8x plus 12. But then these two are like terms. So 6x plus 8x, which is 14x. And then that is our final answer. I'm going to show you one more method here in case this is what you choose to do. The other method is doing something called distributing, which you already know how to do. And essentially, basically, you're just going to distribute twice. First, you're going to take the 4x plus 6 and distribute it to the x plus 2. So you're going to distribute that whole thing to the x and then the whole thing to the 2. So the 4x plus 6 gets distributed to the x, and then it gets distributed to the 2. And then after that, you would distribute again. You would distribute this x, and you would distribute this 2. So 4x times x is 4x squared. 6 times x is 6x. 4x times 2 is 8x. 6 times 2 is 12. This should look awfully familiar. There are the 4 terms that were inside of your box in the last problem, or the same problem when we did it a separate way. And then you still have these like terms in the middle. And you get the same solution whether you choose to do that visual method or you do this one where you end up distributing essentially like a total of 3 times. So that is going to be up to you. Whichever method you prefer is okay. You can do the visual method, or you can do this multiple distribution method. So here is another problem. And we're going to try this one. We'll go ahead and do this one with the area model, or the box method. Since it is a binomial times a binomial, so 2 terms times 2 terms, the box that I set up is going to be 2 by 2. And then I'm going to find the 4 entries, the 4 cells. So this would be 3x squared, this would be 4x, this would be 15x, this would be 20. Then next I would look for my like terms, and then finally I would go through and write out my final answer with those like terms combined. So the 4x plus the 15x, which gives me a 19x. The 3x squared and the 20 don't have any like terms, so they just stay the same. Now I'm not going to redo this one a second time with the distribution method, but you are certainly welcome to give that one a try if you like. Next up we have basically just a special case of what we just did. So you might see a problem that looks like this, the quantity x plus 1 squared. And really that's not any different than the problems we have done so far. What you need to remember is that when you square something, what that really means is that you're multiplying it by itself. So basically, you're going to take the x plus 1 and write it x plus 1 times x plus 1. And then you can do the box method if you want, or you can do the distribution method if you want. I'm going to go ahead and do this one with the distribution method, since we just did the box method for the last one. So if I'm going to distribute this one twice, that means that I'm going to take the x plus 1 in the first parenthesis, I'm going to multiply it by the x in the second one, and then I'm going to multiply it by the 1 in the second one. And then after that, I'm going to distribute the x, and I'm also going to distribute the 1. And if you had chosen to do this one with the area model or the box method, these 4 terms, x squared plus x plus x plus 1, that'll be the exact same thing that you would get as your 4 cells in your area model. Last step, combine your like terms. So the x squared and the 1 don't have any like terms, they're just going to stay the same. But the x plus x is 2x. Now here is another one. Why don't you go ahead and give this one a try? Remember, what's new here is you're going to start by rewriting this as, instead of something squared, you're going to write it as something times itself. And then choose whether you'd like to try this one with the area model or with the distribution model. So go ahead, pause the video, and then come back to check your work. All right, so now that you've had a chance to try this one, whether you did the area model like I did here, or if you did the distribution model, if you did the distribution method, your 4 terms after you distributed should be the same as the 4 terms in the area model. You should get the same answer either way. Next up, we'll look at another set of special cases. Here, these are called sum and difference problems, and you'll notice that the polynomials, or the binomials more specifically, in the 2 parentheses, they're almost the same. The only difference is that one has a sum and one has a difference. So the 3x plus 2 and then 3x minus 2. So they both start with 3x, they both end with 2. The only difference is that one's a plus and one's a minus. And basically there's no difference in your work here, but something interesting happens when you do the problem. So why don't you go ahead, pause the video, try this one either method you want, either the area model or the distribution method, and then come back and check your work. So I ended up using the distribution method for this one. If you tried the area model, that's great. Remember that you will get the exact same 4 terms in the cells of your area model. But what's interesting here is that 2 of the terms, 6x and negative 6x, they're going to be opposites, which means when you go to combine those, they're going to zero out. 6x plus negative 6x is 0. And so, unlike every other problem we've done so far where we've ended up with a trinomial as an answer, here we end up with a binomial. That's going to happen every time you have a problem that looks like this in the beginning, where it looks like almost the same problem, 3x plus 2, 3x minus 2, where one's a plus and one's a minus. So the numbers are the same, but one's a plus and one's a minus. That's anytime you see this sum and difference setup. And we'll make this our last problem for the video. Go ahead and give this one a try, either method, and then come back and check your work. So this one I went ahead and did the area model with. If you did the distribution model, the orange values inside of the cells, you'll have the same 4 terms. You'll notice that 2 of the terms, the 2xy and the negative 2xy, they're opposites. Again, that will happen every time your binomials like this are almost the same, but one's with a plus and one's with a minus. And then that's where they end up zeroing out, and you just get a binomial instead of a trinomial for your answer. So that's it for this video. Thanks for joining us today, and we'll see you next time.